So today's notes are simplifying expressions with real number exponents. And remember, again, from the notes yesterday and a review from last unit, all numbers are called complex numbers, and they're split into two parts, imaginary and real. The imaginary numbers, if they just have an imaginary part, are pure imaginary. And then over on the other side, you have your real numbers. Those are the ones that aren't square roots of negatives. And real numbers are split into two groups, irrational and rational. And remember that rational numbers are the ones that are fractions, and irrational numbers are not fractions. So today we're going to be looking at real exponents. So our exponents are going to be ones that are rational and irrational. And all you're doing is using your properties of exponents to simplify here. So on this first example, notice that the base is the same, so you add your exponents. So you get 11 to the power of 2/5 plus 1/5, which is 11 to the power of 3/5. On the second example, there's a couple different ways to do it, but I would rewrite it in exponential form. So power is 2, root is 3. So x to the power 2/3 over 5, x to the power 5/3. Properties of exponents say subtract. So base stays the same, subtract. You get x to the power -3 over 3, which is x to the power of -1. Make it a positive exponent by moving it to the other side. All right, moving right along. A couple more examples here. On this first one, same base, we're going to add your exponents. So 4 minus square root 5 plus 1 plus square root 5. There's nothing to distribute in the parentheses, so it becomes 4 minus root 5 plus 1 plus root 5. The square root 5's cancel, and you just get 2 to the power of 5, which is 64. Or 32, sorry, 32. Next one, power to a power. So you're going to go 2 square root 3 times square root 3. Square root 3 times square root 3 is 3. So you get 5 to the power of 6. And I don't expect you to know what that is. It's like a really big number. Okay, number 3, again, same base. So you're going to subtract your exponents here, and you need to show your work. You need to show this step. So subtracting your exponents, base stays the same. Distribute your negative sign inside. The 2's are going to cancel, and square root 7 plus square root 7 is 2 square root 7. Now you can go one step further. 3 squared is 9, so you get 9 to the power of square root 7. Okay, number 4. Power to a power, so you multiply. Pi times 2 is 2 pi. Again, you can do 10 squared, which is 100, so you get 100 to the power of pi. Over here, power to a power again. Square root 3 times square root 3 is 4 to the power of 3, and 4 to the power of 3 is 64. Number 2, this is a division sign, so I'm going to rewrite it. 5 to the power of square root 3 plus 1 divided by 5 to the power of 0 times 5 to the power of square root 3. Now anything to the power of 0 is 1. So this is just becomes 5 to the power of square root 3 plus 1 over 5 to the power of square root 3. Now same base, so we can subtract your exponents. So square root 3 plus 1 minus square root 3. The square root 3's cancel, and you just get 5 to the power of 1, which is 5. All right, moving on. Number 3. Again, same base, you're dividing, so you subtract your exponents. So we get square root 2 plus square root 3 So we get square root 2 plus square root 3 to the power of 2 plus pi minus pi. The pi's cancel. So you get square root 2 plus square root 3 squared. Now this is a binomial, so to square it, you have to double distribute. And once you work that out, you end up with 2 plus 2 square root 6 plus 3, which is 5 plus 2 square root 6. And I just did a little math in my head there. Okay, so the next concept, the second concept for this lesson is solving exponential equations. And an equation with a variable as an exponent is called an exponential equation. So basically what you want to do is you want to make your bases equal, and then you're going to set your exponents equal. So for this problem, 8 to the power of 2 plus x equals 2, I can rewrite 8 as 2 to the power of 3 to the power of 2 plus x. So properties of exponents tell me to multiply the 3 by the 2 plus x. The 2 has an exponent of 1, so now I know these exponents are equal. 6 plus 3x equals 1. Subtract the 6, divide by 3, and you get your answer. All right, let's look at another example here. So 5 to the power of x equals, and 1 over 25 can be rewritten as 5 to the power of negative 2. So I know my bases are the same, my exponents are equal, so x is negative 2. All right, same concept. Here, 8 can be rewritten as 2 to the power of 3, so it's 2 to the power of 3x. 1/4 is the same thing as 2 to the power of negative 2, so you know 3x equals negative 2, you divide, and there you go. Skipping along here, I don't think we're going to have time to do all of them. Let's do number 3. So 32 I can rewrite as 2 to the power of 5. And this becomes 2 to the power of 5 over 3 equals 2x, so x equals 5/3. And that's it for today.